Hello, everyone. It's great to be here one more time today. My name is Gary Fowler. I'm the CEO, President, Founder of GSD Get You Done Venture Studios, a premier AI and quantum venture studio located in the heart of Silicon Valley. I'm a 17-time serial entrepreneur with several unicorns under the belt. I was on the original management team at Click Software, which was sold to Salesforce for $1.35 billion, also Eva.ai, an AI HR tech company I co-founded with Dr. David Yang. We believe at GST that intellectual capacity is evenly spread, but opportunities are not. We are a family office. We've got a PR and marketing group called GST Reach, and we also do frontier tech and AI. So, with that, I'd like to welcome you each to GST Presents Top Global Startups, where I spotlight the founders building the technologies that will redefine the next decade. Today's conversation is about something most people never think about, but incredibly important. Yet it could fundamentally reshape how the world produces protein, medicine, and critical biomaterials. By 2050, we have to double the food supply and we can't increase the number of cattle because 26% of the pollution is methane gas from cows. What do? The global protein crisis is not a distant threat. Rising populations, climate pressure, supply chain instability, and land constraints are forcing us to rethink how we manufacture biological products at scale. Traditional agriculture cannot keep up. Fermentation is powerful but capital intensive, and synthetic biology, while promising, still struggles with cost curves and scalability. What if the answer has been evolving for hundreds of years, millions of years? Our guest today is part of a new wave of deep tech founders emerging from India who are thinking far beyond incremental change. Ankit Alok Bagaria is a co-founder and CEO of Loopworm Private Limited, a company building one of the world's largest insect biomanufacturing platforms. Loopworm uses silkworms as living biofactories to produce high-value proteins for health, nutrition, diagnostic, and potentially far beyond. This is not just alternative protein. This programmable biology using nature's own production systems. Ankit has been recognized by Forbes Under 30 Asia in industry, manufacturing, and energy, Forbes 30 Under 30 in India in agritech, and Entrepreneur India 35 Under 35. Well, he's got a lot of 30, 30, 30, 30, 35, 35. And he represents a new generation of founders tackling planetary scale challenges with industrial biotech. So I'd like to welcome to the show. Hi, Ankit.
Hi, Gary. Thank you for having me.
Let's start at the macro level. What exactly is a global protein crisis, and why should business leaders, investors, and policymakers be paying attention to this right now?
So the way we see protein is normally with a food and nutrition angle or for an animal feed angle, but in our 8th, 9th grades, um, like we have studied that proteins are the basic building blocks of life, whether it is, say, the vaccines, which is there in a strain cleaner, or say the enzymes in it, the vaccines, like say the COVID vaccine, a protein in a pregnancy test kit, high value growth factors in biocosmetics, even cell culture media with fuels, say precision fermentation. Everything has proteins. We just know it by different names. And that is where there's a global protein crisis that we are seeing, which goes even beyond food and feed. Like you mentioned, that the world is looking at doubling its protein capacity by 2050. We are expecting almost to feed 10 billion people. But there are different applications that people would be looking at with respect to proteins, and especially with affordable proteins. Affordable, accessible proteins is going to be a key which the global leaders should be looking into.
When people hear insect protein, they think food, but Loopworm is much bigger than that. How do you define insect biomanufacturing?
So, insects are one of the oldest, one of the largest natural biofactories of proteins that we have seen in nature. Like a lot of these species are already domesticated now. In India, we have seen centuries of domestication with silkworms and honeybees. So, the way we see them is yes, the science is cracked, the life sciences piece of it, but the engineering is not cracked yet, where people are still trying to take it up in terms of processing, in terms of expressing and like evaluating different processes as well as different applications with insect-derived proteins. And that is where our concept of insect-derived biomanufacturing comes in, where we are trying to make a platform. It can, like we are making it with the Silkworm platform. There are multiple reasons behind it. I think we would be looking more into it as we move forward. But there can be different insect platforms that people can use to derive insect-based products, and that would be through biomanufacturing innovations.
So help me understand the science. How does a silkworm become a programmable manufacturing platform?
So silkworms, with the popular history that it has, that it fell into a cup of, say, a Chinese empress, and that is where the silk threads coming out from the silkworm cocoons. And like if you look at the silk that we wear, it's 98% plus proteins, which means silkworms have innate capabilities to convert plants, which is mulberry leaves, into proteins. At the same time, this is only the outer shell of the silkworms. The silkworm biomass in itself, which is the silkworm body in itself, is more than 50% proteins. So just look at it, it is eating leaves on one side, converting it into a 98% protein, which is being used as textiles, even for medical sutures or hemostatic bandages, etc., which is silk protein on one side, and silkworm pupa proteins on the other side, which is 50 to 55% protein in itself, which makes it efficient bioreactors to make proteins. Now, this is one logic behind it, where it definitely has natural capabilities to make a lot of proteins for itself. A lot of these proteins can be used for different human applications as well, which people are looking into. Um, but there are other benefits in using silkworms as well. Just to name a few, it is domesticated since a very, very long time. We are looking at silk being a premium clothing since ages. Um, it is so domesticated that like it gives you complete control as, say, a scientist or say an industrial producer to grow silkworms. In India itself, we have 120,000 such producers. We have more than 100 institutes teaching sericulture, which is, or seri-biotech, which is, say, the entire silk value chain related activities from a technical standpoint. So there's a lot of talent availability. There is 150 plus years of documented research, which means that you need not start from the very beginning. You need not start from fundamental research. You can directly jump into translational research. And at the same time, there is 20 plus years of bioinformatics data, which is out there. So, like, it has the innate capabilities. We just have to leverage the information which, say, decades and decades of researchers have given us, and convert it into a very efficient biofactory to make proteins of our choice. Now, a very curious question: how does it happen? Now, like the way we utilize, say, bioresources, say a silkworm, um, like we would have to give it the instruction to make proteins of our choice. To give those instructions, we are using, say, a similar technique, which is using vectors as a gene delivery mechanism into the silkworms. The one thing that we thought of was that instead of, say, building big steel tanks to make the proteins using precision fermentation or using bioreactors with, say, genetically engineered microorganisms or even mammalian cells, why not use the whole machinery? Why not use the entire insect in itself as a biofactory to make those recombinant proteins? And that is what we have been able to demonstrate.
So you're saying my wife's silk scarf is protein.
Yes, it is.
I'm getting hungry all of a sudden. I kind of
Oh,
wondered
yeah.
that stuff.
But it is a biomaterial protein.
But
You have to
it
be
would be at a
careful.
very, it's like a Wagyu beef though, if I ate that. It's amazing. Okay. How did your approach compare to traditional fermentation or cell based bioreactors in terms of cost, scalability, energy efficiency?
So, like if you look at a traditional fermentation-based system or a bioreactor-based system, like you're either growing, say, a bacteria, a fungus, or growing cells there. Now, for all of these three, you need specialized cell culture media, which is like specialized food which you give to cells so that they multiply rapidly. In the process, like because the cells are alone, they don't have the machinery or, say, the entire organ system which, say, any organism has. It has to do a lot of heavy lifting. Now, to prevent the cell to do that heavy lifting, you have to give it broken down food, specialized, curated food, which is super expensive. And that is where the cell culture media based food for the cells, um, because it is expensive, makes the upstream cost, which is the cost to make the protein in the system or in the reactor, very, very expensive. um, Goes without saying that if you're imagining a sophisticated brewery, just imagine, say, a small, you know, tab or craft beer place, but in, say, acres and acres of land, it would be super expensive to construct it as well. When it comes to insects, like, there is no cell culture media. Like the food which is required to make the proteins, the amino acids which is required to make the proteins, it's all there. The machinery to manufacture that protein is all there inside the insect's body in itself, or inside the silkworm's body in our case. And that is where you just have to program it a little, right? Or you have to give the instruction, like send the instruction to the silkworm to make the protein for you, right? And that is where no cell culture media, no expensive bioreactors, no upstream equipments which are required. And that is what makes it almost, say, 40x upstream cheaper. So upstream opex in our case would be like multitudes lower in comparison to, say, a bioreactor based system, which is used to make complex proteins today. Now, when it comes to downstreaming, right? Because, so if I give you some quick numbers, one silkworm is approximately a billion cells. Now, it is a very high, like I told you, like it is a very good machinery to make natural protein. So we have a billion cells at our disposal in just one silkworm. Now, if you look at traditional or, say, conventional systems, you have almost 10 billion cells in 1 liter of a mammalian cell culture, which means that a billion cells in 100 ml. Right, so 100 milliliters of a sophisticated bioreactor-based mammalian cells would be equivalent to, say, a one silkworm pupa, like in terms of the number of cells, which makes it extremely compact to make the protein of your choice. And hence, whenever you're trying to purify the protein to get it out, right, you need not treat, say, tons and tons of volumes of water along with, say, a little bit of your protein of choice, but you have it in a very high concentration right from the very beginning. And that is where your downstream cost also can go down by up to 3 times lesser, with smaller machinery and hence lesser capex. That is where there's dual advantage in doing so. There's a batch time advantage as well, where, say, the batch time of a mammalian cell culture is anywhere between 15 days to 45 days to make a particular protein, whereas in a silkworm we have achieved it in 4 days.
Wow, that's amazing. So is this synthetic biology, or is it manufacturing, or is it something entirely new?
I think it's both. It's synthetic biology with respect to the vectors that we are designing, and it's manufacturing because we are doing it at scales with the help of silkworms. So it's a combo of both, which is enabling us to make proteins at scales.
Could this become a decentralized manufacturing model where countries produce their own high value proteins locally?
Yeah, definitely can be. But like it has to be on the backing of a lot of IP, which we are currently developing. Not just IP at the R&D level, but IP at the scales as well. When it comes to industrial automation, done midstream processes which are unique to this, as well. So it would be on the top of a lot of IP, which needs to be generated before that happens. But yes, definitely a few pieces of the manufacturing, which is not, say, so IP oriented, can be definitely decentralized, and we are already doing it. We don't produce any insects by ourselves. It's entirely contractually farmed, or decentralized, and like we just focus on developing technologies to process them into high value products.
What kind of revenue do you have today?
We're doing close to $1.5 million of revenue, and we are at an ARR of around $2.2 million.
Do you see Loopworm as solving the food security issue, pharmaceutical access, or climate resilience, or all of the above?
Um, One stage at a time. We are currently solving for nutrition and health for animals as well as climate resilience at the same time. I think climate resilience will be at the core of it no matter what application we do. because insects by default are more sustainable, and the processes that we are also developing are sustainable in nature. But when it comes to, say, pharmaceutical applications, we are still 2 to 3 years behind that, and we would be soon doing it.
One thing about I have a lot of Indian entrepreneurs from IIT and IIM, right? And one thing about Silicon Valley is a port to the rest of the world, right? People come there to invest. The valuations for the Indian companies tend to be a bit higher, and people get it, right? I spoke at the United Nations about technology's tool for peace, and I actually talked about by 2050 we have to double the food supply. Have you thought about, and I was just in Africa, in Nigeria, with some of the wealthiest folks in Africa. And so obviously in fact, the population of Africa will be bigger in the not too distant future, bigger than the population of India and China combined, right?
Yeah.
In fact, the population under 30 in the world is the largest growing. So when you look at this, do you look at this as a global play now, or do you look at it, this is an India play and I'm going to do this and let's see what happens?
No, it is definitely a global play. There are innate climatic condition benefits or soil advantages that we have in, say, cultivating mulberry leaves, as well as, say, growing silkworms, but that is there across the tropical belt, across the world. So it's not as if India and only China can grow silkworms. Silkworms can be grown in a number of places. So does the other insect species, right? So we're talking about n number of such species. I am certain that there would be a better insect than silkworm that we find in the future to make proteins. But yes, it is definitely a global play. It is still in the nascent stages. If you look at the industry as well, the money started coming into the industry, especially like a good chunk of money started coming into the industry after 2010, and that too in, say, Europe and US. Asia has seen that coming post 2020, majorly where a bunch of the Southeast Asian, even us in India, as well as a few companies in Africa started coming up, like in insect proteins, where considerable amount of money came in. Now, the way we see it today is there's a larger play of, say, producing it in, say, countries like India and supplying it globally. So it's a global sales play as of now, where we are building the market in different geographies and producing it in, say, frugal countries like India, where there is a cost advantage. But definitely in the future, like if you're talking about 2050, I think insects are going to be like a proper conventional platform by then.
Deep biotech is capital intensive and long cycle. What gave you the conviction to go all in?
A different strategy, one. Second, like the tailwinds behind it. So I'll tell you a story. This is back in 2019 when we were just pondering over starting Loopworm. And we came across two things. People were looking at alternative resources, and insects were standing out. There was a buzz around insects. And then people were also looking at sustainable alternative proteins at the same time. So we saw those large macro level tailwinds around sustainable proteins, which gave us, say, some conviction that yes, there is a market out there which can be leveraged. Like with our primary research, we came to understand that there is a frugality at play as well. Just calling something sustainable is not going to make it sell. So the product has to work. So there is a value divided by price, which needs to be optimized in this market, which was the bigger problem out there, which was, say, manufacturing
I
efficiency.
think it's a little bit different, Ankit. I don't think it's just a value. That's one of the challenges. I think, I remember this course at Stanford is storytelling, right? It's not about that. It's about how people understand what's going to happen if we don't by 2050. If you don't double the food supply, we're going to die. This is a very simple situation. You don't double it, you're going to die. What do we need to do? Hi, my name's Ankit. Let me tell you a little bit about my story. And
Yeah.
so those kind of powerful messages are critically important. I see this a lot because we have a lot of companies that we talk to on a global basis. And, the sense of urgency is today. This isn't about something that we should do, it's we have to do. And the other
Yep.
thing from the farm to the table, we've got to increase protein, right? So we've got to go down through and optimize the entire process. We got a lot of inefficiencies everywhere. And with 8.1 billion people going to 13 by the end of the century, we have to optimize it. This is just one of many. We have a
Yep.
holistic, Aristotle said it's about the sum of the parts equal the whole, right? We've got to take a very holistic approach to everything. But I love what you're doing. So, you look at it, do you think insects, and I mean, because honestly, when I was a kid, we used to laugh about it because you would take insects and they would put them in chocolate and you give them to your friends and ew, I don't want to eat it. I remember as a kid, we used to go to the fair and get these, chocolate dipped ants and things, but now it's not a joke anymore, right? It's not something that's an option. Do you think insects could become the new semiconductor fabs of biology? Are there infrastructure for the next industrial revolution?
Yeah, definitely. Definitely, I believe so because they have the capabilities to just make everything.
And then are there applications you haven't publicly discussed yet that excite you the most?
Yeah, definitely. So we are looking at certain advanced biomaterial applications, which is super interesting. We are working on affordable diagnostics, which is known, but there is just so much to do with biostructural based proteins, and silk is one such example. If you look at it, it is a structural protein, and it is so great to do it. There are a few companies who are exploring, say, a fusion of spider silk with silkworm silk, and making like Kevlar replacements, etc. But that there is still much more to do when it comes to advanced materials, which makes it super interesting because then the application goes beyond, say, bio or food or agri. It goes into defense and aerospace and satellites and whatnot.
I'm into frontier sciences myself. I'm one of 31 people in the world that's had 3 full body stem cell replacements. I've had
Oh, wow.
150 million mesenchymal stem cells put in my body. My biological age went down 22 years. Like it changed everything. And so I can tell you that, I biohacked for a long time. My own background, as I said, is AI. And in fact, I use those language models to be able to help to solve complex problems. And I hacked myself when I had stage 3 kidney disease. I got rid of it in a week. And so, I'm for what you're doing, but we need to take a more integrated approach because it's
Yep.
not one about many, right? The Germans say it's Gestalt, the sum of the parts equal the whole, like Aristotle. I believe it's the same thing. And your one critical key, the other thing is potable water. We don't have enough water. We don't have enough food. We're going to run out of energy. There's only so many dinosaurs and dead plants we can burn. So there's a lot of things we got to do. People forget when you're burning gas in your car, it's an animal or a plant.
True, true, true.
It's crazy. So we got to go down through and we got to figure out how to be able to solve these problems together. So if you look at it, how big do you think this can get? And I'm not trying to, paint a unrealistic picture, but knowing a little bit about myself, there's a lot of, like you said, with spider and the silkworms, you could build Kevlar. Almost sounds like Spider-Man, doesn't it? It starts
Yeah.
to talk. It feels like that. And now, if you start saying we're going to be shooting them out of our hands, that's a whole different deal.
Why not?
Uh,
Everybody.
is this a niche market, or are we talking about reshaping global manufacturing?
Um, Depends on the level of innovation that people have been able to do. It has to be a problem which can solve a bulk issue, and not a niche problem. It will definitely start with something niche. That lays the foundation for people to go more, to understand that, okay, this is the technology which is giving me a product for X. What if I take it to X by 10, right? And that is where there's a blue ocean of opportunities. Now that is how the industry would go, and we have seen this in the past, right? So if you look at the cost of genetic gene synthesis in itself, or even the cost of genetic engineering and bioinformatics, that has gone down considerably, from, say, it was, say, 20 years ago, and that is when new and new
One
models
thing
have
is
come.
people don't get right what you can do. They're hacking it. We're hacking it to 150 to be able to live. People don't understand that this is in our grasp now. It's not like it was before. And if you have, things like quantum computers, The quantum computers that we're using are 100 million times faster than the fastest supercomputer, which means it would take 10,000 years. It takes me 200 seconds right now. So
True,
imagine
true.
the scalability and then solving these problems. You're right. But we don't even know what the limits are. You're saying with a spider and a silkworm, it could be with a spider and some other a worm. You know what I mean? And we don't know what the limits are. But combining these things together, I mean, that kind of science, what do we call that? What kind of science is that when we're taking those component parts and figuring out, for instance, a crab can grow another claw, right? And so now we're talking about things like being able to regrow teeth in your mouth. In fact, in Japan, they're doing it today, right?
Yeah, yeah, yeah. Like, don't know the exact name of it, but in terms of, say, the insect world, people are calling it entomofarming, farming with a PH. So PHARMING, like, which is a very cool term, which I see, where people are using insects as biofactories to make proteins of our choice. And I think it will go beyond this definition as well.
Interesting. No, I love it. So we're coming up to the top of the show. If you want to stay on and Keith and talk a little bit, that would be great. I appreciate you taking your time out of your busy schedule. And Keith, closing thoughts and how do people get a hold of you?
They can definitely reach out to me over LinkedIn or over emails. Like, happy to engage with them. We are definitely keen to explore more and more in terms of how we can use insects as a better biofactory. Happy to share ideas. Not working in silos here. We need not reinvent the wheel here. So that is what we are looking at. We need to think more and more translational than more and more fundamental. And in the process, yeah, we definitely have to look at the commercialization aspects as well as the IP angle of it, but we can definitely do it together.
Now that's great. I appreciate you taking your time out of a busy schedule to join us today, and appreciate all my honors for joining one more time. GSD presents Top Global Startups. My name is Gary Fowler. I'm your host. Stay happy, stay safe, and stay healthy. And we'll be back to you again soon with another exciting edition. And Keith, if you can just stay on, we can talk for a few minutes. Thank you,
Sure.
everybody. Take care of yourselves and have a nice rest of the day.